Hi everyone. Today I would like to introduce an algorithm class in the curriculum of the Department of Electrical Engineering and Computer Science of GIST, Gwangju Institute of Science and Technology. The class title is Introduction to Algorithm and the course number is EC2206. The class has 3 hours a week and instructor is Jin-seok Gong. Before going into details of the class, I would like to define the definition of algorithm first. A textbook defines algorithm as follows. An algorithm is any well-defined computational procedure that takes some value or a set of values as input and produces some value or a set of values as output. An algorithm is thus a sequence of computational steps that transform the input into output. Suppose we have a problem of making juice from oranges. As shown in the figure, the algorithm for the problem takes oranges as input and produce juice as output. When formally talking about algorithms in computer science, the procedure of an algorithm should be described step by step accurately by using a formal language. Now let's take a practical example of sorting problems. The sorting algorithm for the problems take a sequence of numbers as input and produce a permutation of the sequence as output, where elements are arranged in increasing order. For example, the input sequence is A24936. Then the sorting algorithm converts the input sequence to an increasing sequence of 2, 3, 4, 5, 8, 9 as output. The formal algorithm is described in the lower right corner of the slide. As shown in the figure, formal language is used to describe algorithm procedure step by step. In this video, I will not discuss in detail the step-by-step procedure, but we will cover it in detail in class. Let's look at another practical example, searching problems. Again, the sequence of the searching algorithm is a sequence of numbers A and a value V. The output of the algorithm this time is an index I such that the ith element of the sequence has value V, or the output is a special value near if the V does not appear in sequence A. For example, if the input is the sequence of 82496 and the value of 4, then the output of the algorithm is index 3 because the third element has value 4. We will examine the algorithm in detail in class. Here are some more problems we will cover in class. Pattern matching problems, knapsack problems, matrix chain product problems, longest common sequence LSC problems, shortest path problem, minimum spanning tree, MST problems, etc. For each problem, we will define input and output and design an algorithm. Also, if there are multiple algorithms that solve a problem, performance comparison will be conducted to find the best algorithm. This is a brief summary of GIS's Introduction to Algorithm class. Thank you for watching.